All right, here we go. So, now we're going to talk about graphing logarithms. So, we're going to start out with a parent function, okay? So, first of all, logarithms will take the form of f of x equal to logarithm. There's got to be some type of base, and then there's got to be the variable x. Cool? Now, you do realize that a is the same base as an exponential, right? Do you remember what were the restrictions for a for exponential? A cannot be 1. What else? What's that? What about 0? The base can't be 0, but I can write that in a different manner. Good. A has to be greater than 0. Cool? And then there was one last thing we talked about, exponentials. I don't know if you remember. No. It has to be positive. Cool? All right. All right. The last thing is that A has to be a real number, guys. Cool? An element of the real number. I don't know why. Like, it has to be a real number. It has to exist. Can't be imaginary. Cool? Are we good? Yes? All right. So let's start out with a parent function to keep this simple. So I'm going to start out with f of x is equal to the logarithm base 2 of x. Okay? All right. So we're going to create a table to make this simple. Okay? All right. Number 1. This would be the inverse function of what? 2 to the power of x. Cool? So, the parent function of 2 to the power of x. Yeah, I mean, but if I solve for, like, if I find the, like, if I actually solve for the inverse, I have to switch x and y, remember? And then when I solve it, I'm going to get y equals 2 to the power of x. You with me? So, 2 to the power of x and logarithm base 2 of x, those are inverses of each other. Okay? So, do you remember where 2 to the power of x would have an asymptote? Y is equal to 0. You with me? Now, the logarithm is the inverse. So how do you find an inverse again? You switch x and y. So instead of having an asymptote at y equals 0, we're going to have an asymptote at x equals 0. So we're going to have a vertical asymptote. So I'm going to go ahead and write down information. So vertical asymptote at x equals 0. Correct. For logs, it's only a vertical asymptote. Yes?
Oh, okay. So what in the problem would change the vertical asymptote? Would it be what's inside the circle?
Yes. And when we do transformations, we'll talk about it, which is basically going to be the left and right movement. Cool? All right. So basically now, you've got to pick x values that you know the log of. You're with me? So when you're plugging in numbers into a log, it's very strategic. Are you guys with me? So think of powers of 2. What powers of 2 do you know? 2, 4, 8, 16, 32, 1/2, 1/4. Those are the numbers that you're going to utilize. You're with me? So for example, if I put in a 2, what is the logarithm base 2 of 2? 1. So then I have the point 2, 1. So 2, 1. All right. What if I plug in a 1? What is the logarithm base 2 of 1? 0. So I have the point 1, 0. What other powers did you say you know? 4. What is the logarithm base 2 of 4? 2. So 4, 2. And just for fun, let's see. What if I put in a 1/2? Yeah, what's the logarithm base 2? Negative 1. Okay. So 1/2, negative 1. Okay, based on that, do you kind of already have an idea what this looks like? I mean, I have plenty of points. All right, so I'm just going to connect them. It's going to go in this direction, and then this is going to follow the asymptote downward. Okay? Are we good? So this is what the parent function looks like, so let's describe it real quick. We know it has a vertical asymptote at x equals 0. Does it have an x-intercept? At x equals 1 or 1, 0. Cool. Does it have a y-intercept? No. What's the domain? So 0, comma infinity, not including the 0. And what is our range? Negative infinity to infinity. We're good so far? All right, one last thing I'm going to ask you is this function increasing or decreasing? Increasing. Very good. All right, any questions? Yes. You sure? There are no horizontal asymptotes. No. Yeah, never. Okay. All right. How we doing? We're good? Okay. So, the last thing we're going to try is we're going to try a couple of examples where there's transformations. Okay? Guys, here we go. Okay. So, f of x is equal to. All right, let's pick, I don't know, base of 3. Cool? And then let's say we're going to do a negative in the front of the log, and then on the inside I'm going to do negative 3x plus 3, and then a plus 1 on the outside. Okay? Now, we've covered transformations in the past with other functions, so nothing should change about that with the logarithm. So first I'm going to ask you to list the transformations for this. Okay? So, do you notice anything in particular that I have to do before I start listing transformations? Take out the negative 3. So that gives me negative 3 times what? X minus 1. I need to do that in order to successfully identify how much I'm moving left or right. Okay? All right, so let's list the transformations. The negative all the way in the front does what? So reflect x-axis. All right, the negative inside the parentheses reflect y-axis. What does the 3 inside the parentheses do? Horizontal compression. You can say 1/3 or 3. I'll accept either one. You with me? So I'm going to just put a 3 here. Cool. All right. What is this minus 1 going to do? Right 1. And then lastly, the plus 1 at the end would be up 1. Okay? So before we get started, I will go ahead and tell you that the transformation that matters for the vertical asymptote is what? Moving right or left. Okay? That is the only transformation that would affect this. So therefore, before I even start thinking about what numbers to plug in, you can tell me where the asymptote is located. Cool? X equals 1 because they moved to the right 1. You with me? So we have a vertical asymptote here at x equals 1. Are we okay? All right, so that's where I'm going to start with for my graph. All right, so I'm going to put the asymptote at x equals 1. All right, ready? Now, we could just take the parent function and perform all these transformations ourselves, but that is kind of challenging to keep up with, okay? So instead, we're going to plug in values, okay? But we're going to plug in very strategic values, okay? So I'm going to show you a strategy that could work for this. Ready? Okay, so here's the strategy. What you're going to do is you're going to take whatever's on the inside, which in this case is negative 3x plus 3. And you got to set it equal to different powers of 3 that you know. So tell me powers of 3 that you know. 9. So I can set it equal to 9. What else? So negative 3x plus 3, I can set it equal to 3. One more. What's that? 27. So I can say negative 3x plus 3 is equal to 27. The reason why I'm choosing these values is I know the powers that would produce that. Agreed? Okay, so what you're going to do now is take each one of those and solve for x. Okay? Yes? Could we make it a 0? What do you guys think? Can I make it 0? No, why not? You can make the power, like nothing to a power will give you 0. However, we can get a 1. We can set it equal to 1. So do you want me to also include that one? Yeah? Okay. So negative 3x plus 3 equal to 1. All right, so let's solve all of this for x. All right, so let's start out with the negative 3x plus 3 equals to 1. So what happens? So minus 3, and then divide by, so that gives you, so 2/3. Oof. I mean, you can handle a fraction, but if we can avoid them, then we'll avoid it. Fair enough? All right, the next one. Negative 3x plus 3 equals to 9. So, x equals, you said, minus 2. Beautiful. So that one's pretty. I like to use that. It's an integer. Cool. All right, what about the next one? X equals 0. Also relatively nice, right? What about the last one? Negative 3x plus 3 equals to 27. X equals negative 8, right? Cool. Any questions so far? Here's what you literally found, guys. You found the x values that you're going to plug into this function to successfully graph it. Okay? So you're going to make a table with the values that you just found. So x. You're going to try 2/3 if you want to, negative 2, what was the other one? 0, and what was the other one? Negative 8. We're good? All right. So we're going to go up to the function, and then we're going to try one by one. Okay? So let's try the fraction. I know you don't like the fraction, but let's try it. If I put in a 2/3 into the x, right? What is 2/3 times negative 3? Negative 2, right? Plus 3? 1. What's the logarithm base 3 of 1? 0, right? And then this entire thing becomes 0, which means if I add 1, I get, so when I plugged in 2/3, I get a 1. And then if I need to slow down, you let me know, okay? Exactly. That's why, like, if you do all this work, you're going to know a lot of the information beforehand, okay? All right, if I plug in negative 2, negative 3 times negative 2 is 6. 6 plus 3 is 9. Log base 3 of 9 is 2 times a negative 2 plus 1, negative 1. Cool? All right, plug in 0. That gives me log base 3 of 3, right, which is negative 1 plus 1, 0. And then the last one we found was negative 8. So negative 8 times negative 3 is 24. 24 plus 3 is 27. What is log base 3 of 27? 3, because 3 to the power of 3 is 27. So times a negative, that's a negative 3, plus 1 is a negative 2. So now you have 4 points, which is more than sufficient to come up with the graph. Okay? So I'm going to go ahead and graph this. So we have negative 2, negative 1, which is about right here. 0, 0, which is right there. Negative 8, negative 2. So 1, 2, 3, 4, 5, 6, 7, 8. Negative 2. It's about right there. And with those 3 points, I know what's going on. You with me? You could plug in the 2/3 1, which the 2/3 1, that'll be about right here. But that was sufficient for me to know that this is going in this direction, and then it's going to go upwards. Cool? Which, think about this. We had 2 reflections, right? If you think of the parent function, if I reflect it over the y-axis and the x-axis, it should end up the way that it did. Are you guys with me? Questions about this problem? Are you sure? Would you like me to do another example? Yes? Okay. Does anyone still need the information on the board? Yes, sir. Yes. Good question. On the test, I'm going to ask you to plot at least 3 points. You can plot as many as you want to, but at least 3. We will have a quiz on the quiz as well. Oh, yeah, I mean, for this graphs, I would also ask you anything about domain, range, etc. So you should be able to answer those. You with me? So this one, in this case, is also increasing. Yes, sir. Okay? All right. Ready for the next one? Okay. let's say we have something along the lines of y equals 3 logarithm base 2 of 1 minus x plus 1. So 3 logarithm base 2 of 1 minus x plus 1. All right. Anything I need to do before I begin? Yes. So we can say 3 logarithm base 2, and I can say negative x plus 1 plus 1, right? But now that I switched it, what do you realize? There's a negative, so what do you need to do? Take out the negative. So then we got one extra step, so 3 log base 2, take out the negative, and then you'll be left with x minus 1 instead of x plus 1. And now we're ready for transformations. Okay? Oops, sorry. All right, the 3 would be a vertical stretch. The negative inside the parentheses would be a reflection over the y-axis. The minus 1 inside the parentheses would be right, 1 unit. And the plus 1 at the end would be up, 1 unit. Cool? Any questions about transformations? All right, so then you tell me, based on the first example, how would you begin this problem? Set what? Well, we can find a vertical asymptote first, for sure. So my vertical asymptote would be at x equals 1 again, right? Just because I moved to the right one. Cool? All right, so now we have a vertical asymptote. Now what? So powers of 2, basically, right? So you said inside the parentheses. So it really doesn't matter which set of parentheses you choose, to be completely honest with you. So I'm going to choose the top one, okay? So I'm going to say 1 minus x. So tell me powers of 2 that you know of. 2, and then 1 minus x, what else? And then 1 minus x equals 8. And then let's go backwards. Instead of going forward, 1 minus x equals, we can do 1/2. Cool? All right, so let's figure out our x values, which means for the first one, x would equal to negative 1. Very good. For the second one, x would equal to negative 3. For the third one, x would equal to negative 7. And for the last one, x would equal to negative 1/2. No. Is it? It's positive 1/2. Yes? Cool? Yeah, because 1 minus 1/2 would give you 1/2. Cool? All right, are we good so far? Okay, so now I'm going to start graphing this. Okay, so I will start out with my asymptote, which is at x equals 1 again for this problem. And then I'm going to find some points. So here's my table, x, y. All right, we'll start out with the very first number that you found, which was negative 1. Okay? All right, guys, if you plug in negative 1 into the x, what is 1 minus a negative 1? 2. What's log base 2 of 2? Times 3 plus 1, 4. So I plugged in negative 1 and I get the point 4. So negative 1, 1, 2, 3, 4. So that's here. Cool. All right, the next value we're going to try is negative 3. So what's 1 minus negative 3? What's log base 2 of 4? With the 3 in the front would make it 6 plus 1. So I have negative 3 comma 7. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Cool. All right, the next one you guys got negative 7. I'm a little worried about that one because I think it's going to be too large, but we'll figure it out, okay? So if I plug in negative 7, then I get 1 minus negative 7, which is 8. Log base 2 of 8 is 3 times the 3 in the front plus 1 is, so that's not terrible. I think we can fit it in here. So negative 7, so 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And personally, even though I know we have an extra x, I know what's going on. You with me? So I don't need to plug it in. So what I'm going to do is I'm going to connect these points. This is going to go in this direction. It's going to go downward. And then it's going to go in this direction. Cool? All right. On this problem, I am going to ask you one more thing. So there should be no problem finding the domain, right? You're okay with that. The range, you're also okay, right? What if I ask you to find the y-intercept? How would I find the y-intercept? You plug in 0 for x, right? So I need to figure, okay, my y-intercept would be y of 0 is equal to, all right, that gives me 3 logarithm base 2 of 1 minus 0 plus 1, right? Okay. What's the logarithm base 2 of 1? 0, right? Yes? So that one came out pretty nicely. So that means that my y-intercept is going to be at 0, comma 1, right? Because I still have to add the 1 at the end, right? Which makes sense. It's kind of right here. Look, I mean, I honestly, it was by accident, but I didn't really think about that. You with me? All right. So how do you find a y-intercept? You plug in 0 for x. How do you find an x-intercept? You plug in 0 for y, which means I have to set it equal to 0. So this one's the ones that are a little bit more difficult. So in this case, I'm going to have 0 is equal to 3 with the logarithm base 2 of 1 minus x plus 1. Now, we're eventually going to talk about solving equations. We're not there yet, so I'm kind of getting a little bit ahead of myself here. But let's see if you remember anything from Algebra 2. Any thoughts of how I can solve this? Subtract 1 and divide by 3. So that would give me a negative 1/3 on the left-hand side, and it would leave me with a logarithm base 2 of 1 minus x on the right-hand side. Exactly. Turn it to an exponential. So if I turn this into an exponential, I'm going to go in this direction. It would be 2 to the power of negative 1/3 is equal to 1 minus x. I don't really need the parentheses. I got to be honest. I don't really know why I wrote them. Okay. Now, I don't expect you to know what 2 to the power of negative 1/3 is. You with me? Like, I don't. So if you don't have a calculator, that's what you're just going to leave it as 2 to the power of negative 1/3. Are you with me? But you can still solve for x. How can I get x by itself? So can I say then that x is equal to 1 minus 2 to the power of negative 1/3? And that would be my x-intercept, which I would not expect you to know where that is if you don't know what 2 to the negative 1/3 is, but you can still find the x-intercept algebraically. Well, you kind of technically did. It's just not in the exact location per se. No, no idea. I mean, I can try. Let's see. Let's see. So 2 to the power of negative 1 over 3. There you go. 0.7. I was never going to get that. Cool. All right. Any questions about anything that happened with graphing today? Okay. Then for homework for this, it's not web assigned. There is a worksheet that you can find on Canvas. I believe there is like 4 questions just like I did for the other. If you want more practice, just let me know, and I'll be happy to give you more practice. All right. That's it for today.